Now that we have learned so much about matrices, alright, it's about time we find out how do we apply matrices, okay, to solve questions like simultaneous equation. Okay, let's take a look. Now, in this example, we're supposed to use matrices to solve the simultaneous equation 4x plus y equals to 13 and 6x minus y equals to 7. Okay, of course, you are supposed to be able to solve this simultaneous equation without using matrices at all, isn't it? Okay, but now since the question insists that we have to use matrices to solve this, okay, we have no choice. The first thing that we must learn is to convert these two equations, these two linear equations, into matrix form. Okay, now what do we take note of? Now the first thing that we must learn is to take note of the coefficient. Alright, so this is 4x plus 1y, so we have 4, 1. Okay, and this is 6x minus 1y, so this will be a 6, negative 1. Okay, now we multiply by xy, okay, and that will give us 13, 7. Alright, so this is precisely the same pair of equations here, okay, but in matrix form now. Alright, now as you can see, this becomes a matrix multiplication. So when you work out your matrix multiplication, alright, you will get back exactly the same equations. Alright, let's take a look. So this is the row, this is column, so you have 4x multiplied by 4 multiplied by x, that will give us a 4x. Okay, and of course we have 1 multiplied by y, and that will give us a y. Okay, will be equal to 13. So you see, as you work out this matrix multiplication, okay, you will end up with the same equation. Alright, so let's take a look at the next equation. We have 6x, alright, minus y equals to 7. So when expanded out, you will get back exactly the same pair of equations. Okay, so this is how you convert it into a matrix multiplication. Okay, matrix form. Alright, now the next thing is, okay, good, so now I change it to matrix form. How are we going to solve it? Okay, now to solve a simultaneous equation simply means that you're looking for the value of x and y, isn't it? So now you take a look at this and you go, okay, now I need to find xy, and therefore I need to get rid of this matrix here, isn't it? Now, but then you remember that, hey, there's no such thing as divide a matrix, isn't it? So I can't just divide the matrix over and get my xy. Okay, so what am I going to do? Alright, now you relies a lot on the concept that we learned earlier on, okay, regarding inverse. Okay, so when I have inverse matrix multiplied by the matrix itself, we'll get back to I. Okay, and we learned as well that I is an identity, so any matrix multiplied by I will give us the same matrix. Okay, so what happens here is that we're going to make use of this concept here to get rid of this matrix. Okay, which means that we're going to multiply, okay, the inverse of this matrix, okay, and therefore to get rid of it, to cancel away the effect. Okay, so the first thing that we have mentioned earlier on, to find the inverse of any matrix, we first have to find its determinant. So let's figure out the determinant of this matrix 4, 1, 6, negative 1. Okay, shall we? So how to find the determinant? Well, it's AD minus BC, isn't it? So 4 multiplied by negative 1, that will give us a negative 4. Okay, and then minus 1 multiplied by 6, and that will give us a 6, so that will give us negative 10. Okay, so this is the determinant of this matrix here. Okay, and therefore the next thing we know we can find will be, of course, its inverse, isn't it? So the inverse of this matrix will be 1 over the determinant, alright, multiplied by, okay, remember A and D will swap places. Okay, so alright, and of course the B and C will then becomes negative. Okay, so this is our inverse matrix, alright, of this 4, 1, 6, negative 1. Okay, now what good does it do, we may ask? Okay, well, we're going to make use of this concept, isn't it? So which means that we're going to multiply this inverse matrix, alright, to this matrix in order to get rid of it. Okay, but as per what we have learned earlier on when we were younger, is that, well, you cannot just simply multiply to one side of the equation. Alright, they'll make the equation not balanced. So of course, when you want to multiply to any side of the equation, you make sure you multiply the same thing to the other side. Okay, so we're going to multiply the inverse to the left hand side. Okay, so you're going to multiply this matrix, this inverse matrix, to this matrix to the left hand side. Okay, and of course we must do the same to the right hand side. Okay, so now what happens here is that, well, this is the inverse of this, and therefore they will cancel each other. Okay, so you end up with an I, right? So this I, when multiplied by xy, will simply give us an xy. So basically it's as good as not being there. Okay, so let me scroll down a little bit, and okay, we have more space now. Okay, so now as you can see at the left hand side, what we have successfully done is that we have isolated our xy. So which means that all we have to do, all that is left to do now, is to work out this matrix multiplication to the right hand side in order to get our xy value, isn't it? Okay, now one thing that I want to caution you excuse me, is to remember, okay, that as per what we have discussed earlier on, that A multiplied by B is in general not equal to B multiplied by A in matrix, isn't it? And therefore, alright, when we multiply to the left hand side from the left, okay, we must make sure we multiply to the right hand side from the left as well. Okay, which simply means that, well, if you were to multiply the right hand side this way, okay, you get entirely different answer. Alright, so no, this is not what we want. Okay, so bear in mind, the order matters a lot. Okay, so let us, now we know that, well, this is our xy equals to this, so all we have to do now is to work out our right hand side, isn't it? So therefore, okay, now negative 1 over 10 is a constant, so we'll leave it alone. Okay, so this is a simple matrix multiplication, so let us just quickly work it out. So we have row multiplied by column, so we have negative 13. Okay, negative 1 multiplied by 13, that will give us negative 13. Okay, plus negative 1 multiplied by 7, that will give us negative 7. Okay, so now this is a 2 by 2 matrix, and this is a 2 by 1 matrix, and therefore our answer will be a 2 by 1 answer. And therefore we know that, well, there's only one column in our answer, so there's no more to go. So we go on to the next row then. Okay, so we have negative 6 multiplied by 13, that will give us a negative 78. Okay, and of course 4 multiplied by 7, that will give us a 28. Okay, so when we work this out, okay, we have negative 10, and of course this will give us a negative 20, and of course this will give us a negative 50, isn't it? Okay, and therefore when multiply in, we have of course positive 2 and 5. So what we have figured out would be this, that xy is equal to 2, 5, and therefore, I mean, it's obvious, isn't it, that x is equal to 2 and y is equal to 5. So we've solved the simultaneous equation by using matrix. Okay, so this is how we use matrices to solve simultaneous equation. Now, how about an example like this? Okay, now use matrices to solve this following simultaneous equation. It's the same thing, okay, as for what we have discussed earlier on. Therefore, the first thing we take note of is, of course, the coefficient of the simultaneous equation here and here. Okay, so we have 2, 1. Okay, and here we have 4, 2. Alright, and of course we have xy equals to 2, 5. Okay, now one thing again has to, that you guys have to be extra careful is to look out for that the fact that, well, this has to be x and then y, because sometimes the question will swap the x and y. Okay, so you got to be careful with that. Alright, so make sure that this is xy, xy, and this is xy. Alright, so now let us, based on what we have learned earlier on, alright, we know that now, okay, in order to find xy, we have to get rid of this matrix, and therefore the first step is, of course, to find the inverse of this matrix. And to find the inverse of this matrix, the first step will be to find its determinant. So we have 2, 1, 4, 2. Okay, the determinant of 2, 1, 4, 2 will be 2 multiplied by 2 will give us a 4, isn't it? Minus away 1 multiplied by 4, which will give us a 4. And we know that the determinant of the matrix is a 0. And then we now know, hey, wait a minute. If the determinant is 0, didn't we mention something about determinant being 0? Well, determinant is 0, basically you can't find the inverse, isn't it? Because, to find its inverse, you need to, first of all, 1 over its determinant, which is 0. So, all of us know that, well, there's no such thing as 1 over 0. You cannot divide by 0. So, wait a minute, what does it mean now? Hey, there's no matrix, there's no inverse matrix for this matrix? Yes, exactly. So, there is no inverse for this. So how can it be? When there's no inverse for this matrix, then how am I going to find my x and y? Well, it simply means that there is no solution for your x and y. Okay, no solution. Now, then you may ask, okay, how can a pair of simultaneous equation be no solution? Okay, well, simple. Okay, the fact of the matter is that, well, this pair of simultaneous equations, they are both linear, isn't it? And therefore, okay, in order to have a solution for a pair of linear equations, okay, it will be simply what? The intersection point. So when you have an equation like this and an equation like that, okay, the intersection point will then, of course, be the solution to the simultaneous equation, isn't it? Okay, so graphically, what does it mean? When you sketch out the graph of these two, what does it mean? Does it mean that they don't intersect at all? Well, these two lines here are the sketch, or no, the plot, okay, the graph of the two equations that we saw, isn't it? 2x plus y equals to 2, 4x plus 2 equals 2y equals to 5. Okay, so this line here and this line here, alright, obviously they share the same gradient. Okay, you can work it out. You can find the gradient yourself. Okay, you realize that they have the same gradient, and therefore they are parallel to each other. So when two lines are parallel to each other, they will never meet. Okay, so when they never meet, there's no intersection points, and if there's no intersection point, okay, then there is no solution, and therefore, in our case here, this is precisely what we're faced with. Okay, this pair of simultaneous equation has got no solution because they are parallel. Alright?